So we're going to do kind of the same thing as what we did before. We're going to add rational expressions, but our denominators are going to be just a little bit different this time. All right, and it's just one little added thing that we have to do to figure out what our denominator is going to be. So I've talked about this just a little bit before, but let's talk about this again. Least common multiple, remember LCM? All right, you've probably seen that before, right? That's what it stands for, least common multiple, and that's what we're going to try to do. So if I asked you to, I don't know, I might have done this before, but I'm going to do it again. Like 4 over 15. What if I asked you to add those fractions together like that? What's the one thing that we have to do first? Common denominator, okay? So how would you find a common denominator? You got to find a number that 12 divides into and 15 divides into. And you want to find the smallest number, okay? 3. 12 doesn't divide into 3. 3 divides into 12, but we need to find a number. So the number we're going to get is going to be bigger than 12 and 15, okay? Because 12 has to divide into it evenly. So whatever this number is divided by 12, and whatever that number is divides by 15, okay? So we could sit here for a long time and just try to think of big numbers that work, but there's a little method. I think I've shown this to you once or twice, but let's go through it again. So what I do, if you get relatively larger numbers, I would take those numbers and then I would break them down into their primes. All right, so this first part, the prime part of it, we're not really going to do with this lesson. It's already kind of broken down into its primes, but it's after we break it down to its primes is what we want to really look at. So what times what is 12? Yeah, 4 times 3, and then, but 4 is not prime, is it? So break that down even further. What's that going to be? 2 times 2 times what? Times 3. 2 times 2 times 3 is 12. They're all prime numbers. You with me? All right, that's easy. What about 15? Yeah, it's only 3 and 5. That's the only thing, right? You agree? Watch, I'm going to put a little wall up between the two things. So I've got this group of numbers right here, and I've got this group of numbers right here. So what we're going to do, in order to find the least common multiple, in order to find the number that 12 divides into and 15 divides into, what we're going to do is see what numbers show up, all right? What numbers show up? Well, I got some 2s, I got some 3s, and I got a 5. Agreed? All right, so let's take the 2s. Well, there's 2 2s over here, and there's none over here. They don't have to be in both places, okay? A lot of students get confused on that. They don't have to show up in both places. They just got to show up somewhere. All right, well, they show up here, the 2s, and they show up twice, so I'm going to use them both. So I'm going to put 2 times 2. So here's my least common multiple. So I'm going to take these because it shows up right there, and it shows up twice, so I put 2 times 2. What other number shows up? What's the next biggest number? 3. So I've got 1 3 here, but I've got 1 3 here. Does it show up any more places in one place than it does the other? No, it only shows up how many places? Once. It shows up once here and once here, so we only pick one of them. You with me on that? We only pick one of them. If it shows up once here and once here, we still only pick one because it only shows up one time in either place. So I just pick one of the 3s. It doesn't matter which 3 you pick. Let's just pick that one. Good so far? What other number shows up here? A 5. It only shows up once. Again, it doesn't have to be in both places, but it shows up once. Agreed? All right, so I pick one of those. Now, what do I do with all those numbers? Multiply them together. So 2 times 2 is 4, times 3 is 12, times 5 is 60. Excuse me. So that is my, man, I can't clear my throat. So that is my least common multiple. Everybody with me? That part right there, we're really not going to do in the actual problems that you're going to be given. Okay. I'm sorry. I should say this. This part right here, breaking it down into its primes, we're not really going to do. But what we did right here, I picked 2 2s, I picked 1 3, and I picked 1 5. That's something that we're going to do in the next little section here. But they're not just going to be regular numbers. What are they? They're going to be, you're going to have x's, you're going to have x squared, you're going to have stuff like that. Okay? Well, they're just going to be variables. You're going to have variables You're going to have things that are being added, subtracted, squared, and all that kind of good stuff. Expressions, algebraic expressions. But let's do this. Now we're at a point where we found the common denominator. That's really the only new stuff we're doing today, is just how to find the common denominator. Before, the common denominators were usually pretty simple, but now they're going to be just a little bit trickier to find. But the next step is going to be exactly the same as what we've been doing the last few days. We ask ourselves, what do we do to 12 in order to get to 60? What do we multiply that by? Multiply it by 5. So what do you do to the top? Multiply that by 5, and what do you get? 35. Okay? What did you do to 15 to get to 60? Multiplied it by what? 4. That's right, because there's your 15 right there, right? Times 4 is 60. So we multiplied 15 by 4, so what do we do to the top? Multiply that by 4, what do you get? 16. And then now you just add them up, whatever that is. What's that? 4, 5, 1, 51 over 60. So that's how you would add those fractions together. Well, that's not really what we're doing. It's leading us up to what we're doing. I said that a couple times already, right? This isn't exactly what we're doing. This isn't exactly what we're doing, but some of the steps, like right here, this is the key to what I just did right there. That's the key, is how to find the common denominator using the least common multiple method. That's the method right there. Okay? So now, what everybody's been waiting for, let's actually use what we learned to do a problem that they're going to give you. All right? So the first one, and again, they're not going to give you a whole bunch of these. This is just, again, leading you up to the next thing, because we're going to add fractions together. All right? So they ask you, find the least common multiple of these two things. All right? Yep. Uh-oh. No, it's not that hard at all.
No.
What? I warned you.
Why don't you just do a fraction?
We will, don't worry. You're so pessimistic, Gage. That's right. Listen, Anicia, you just got to believe. There you go. I like that. You just got to believe. All right, here we go. Do you remember the part that I circled right here? Everybody looking here? So watch. Right here, this is what we're doing. This little part right here is what we're doing right now. All right, so remember what we did. What do we do here? We look to see what shows up, okay? Well, a 2 and a 2 shows up, so I multiplied them together. See it? A 3 shows up. It shows up once here and once here, so I only take one of them and put them right here. What else shows up? A 5. So I take the 5 and I put it here, okay? So keep that in mind. That's what we're doing on this. So what are we going to do? Let's look at this and look at this. Everybody see those two things? Okay, so what we're doing is we want to find out what numbers show up, and if they show up more than once, we take them both. If they show up in both places, then we just take one of them. All right? So let's see what we got here. There is an x that shows up. So what are we going to do? We're going to put down an x. What else shows up? Well, we got an x minus 1. Let's do the one that's next to it. Everybody watch. Guys, in fact, come on. I know, but it's disturbing me. Okay, so I can't have you talking while I'm talking. I know you're helping each other. I get it, and I appreciate that, but I can't have you talking when I'm talking. All right. So here we go. What else shows up? An x shows up. Now, is there an x by itself over here? No, there doesn't have to be. It doesn't have to show up in both places. It just has to show up somewhere, okay? I also have an x minus 1, but I got 2 of them here, don't I? All right, and I only got 1 of them here. So if it shows up more places in one place than it does the other, I take the one that shows up the most number of places. So I got an x minus 1 twice here, right? That's what squared means. I get an x minus 1 here. So which one do I choose? The one that's squared, the one that shows up the most number of times, all right? So I take that. You with me on that? What else do I have? I got an x plus 1. Well, I also got, all right, I got 3 x plus 1s right here. That's what it means to cube something, right? So I got 3 of them. So which one do I pick?
Either one.
No, not either one. I picked the one that shows up the most number of times. I just said that. I wish you would listen. So I picked the one that shows up the most number of times. It shows up 3 times here, so I picked the one that shows up the most number of times. So that right there is my least common multiple.
That's the answer?
For this problem.
That's so easy.
It is so easy. That's right. So find the least common multiple. I just found it, okay? But you don't think we're going to stop there, do you? Because what did we do? Once we found the least common multiple, what did we do? We used it to find a common denominator.
Hey, Mr. Hammer.
What?
What you do with the 4?
What 4?
X minus 1. Which is like what?
Oh yeah, there should be a positive 4.
A 4? Where's a 4? Oh, the 4. Yeah, right there. Exactly right. There's a 4. Good call. I missed it. All right. I completely overlooked it. Right. There is a 4 there. So you got to include that as well, don't you? All right. And so you got to multiply that as well. You were paying attention. I wasn't. All right. So there you go. So let me go back to what I was saying before. Everybody listen now. All we did right there was basically find the 60. Does it make sense? On this problem, I'm just relating these 2 problems to each other. So what do you think we're going to do now? Okay, we found the least common multiple, but on the next example, what do you think you're going to have you do? Of a fraction. That's right. You're going to give you 2 things, add them up, subtract them, whatever. Okay, and you're going to have to find a common denominator and then find what the numerators were. All right? It's very similar to what we've been doing. It's nothing really new. This is the only thing new, is to find a denominator that looks something like that. So let's do this next problem. And that's the nope, I got two more examples, okay? And they're kind of the same. Kind of. This is example 8 if you want to look in the book. All right? Here we go. Ready to write this down? Good. X squared plus 3x plus 2. And then we're going to add. So we're going to add these fractions together. X squared minus 1. All right. Now, hopefully, you're looking at this and you say, oh, I know it. I know the first thing I'm going to do. I don't like the denominator looking like that. So what can I do to it to change it? I can factor it. Do you see that right away? Yeah. You should recognize it. As soon as you see that, you're like, oh, I don't like it like that. I want to factor it, okay? What about this one right here? Do I want to leave it like that? I can factor that as well, can't I? All right? Again, this is something, this first step is nothing new. We've done this before. All right, so we're going to factor it. So what times what is 2? This is super easy. This is probably one of the easiest trinomial factorings you'll ever do. What times what is 2? And the same 2 numbers add up to be 3. 1 and 2, that's right. So it's x plus 1 and x plus 2. All right, I just had to think of 2 numbers that multiply to be 2. And that's not too hard because there's only 2 numbers that multiply to be 2, right? It's my only option. All right? Well, you could get -1 and -2, I guess. But there's no way you're going to pick the negative because they have to add up to be positive anyway, right? So 2 times 1 is 2. 1 plus 2 is 3. Everybody got that? All right. That's super easy factoring. Now, this is one of our special factorings. Do you recognize this? It's a, give me the name of it. Difference of 2 squares. That's right. So how do I factor a difference of 2 squares? Yeah, I usually put the plus first. It doesn't matter. But I usually put x plus 1 and x minus 1. Because when you multiply them together, 1 times -1 is -1, right? When I add them, right, outside, inside, so when I add them together, what do I get? I get a 0, 0x. There's the 0x. Do you see it? So it works. Then the top, I just keep the same. So that's nothing new. That has nothing to do with what we talked about for least common multiple. But now that I've made this into factors, now what I can do is now I can look at this, and now I can look at this and find my common denominator. And we're going to do it by that least common multiple. So what do? We look to see what numbers show up, right? And if it shows up more in one place than the other, we take the one that shows up the most number of times. Everybody got it? So what shows up? An x plus 1. Do I have an x plus 1 over here? Yeah, but I only have one of them, so I don't pick them both. I just pick one. All right, so my common denominator, I'm going to put this over one denominator. So my common denominator is x plus 1 is one of them. What else shows up here? I already got an x plus 1. What else shows up? Okay, I got an x minus 1, and I also have a what? An x plus 2. I already did the x plus 1. Okay, I've already taken care of the x plus 1. I said, what else do I have? I got an x minus 1. Now, it only shows up in one place. Is that all right? Yeah, it can show up just in one place. It doesn't have to be in both spots, okay? It just has to show up somewhere in here. And then, what else do I have that shows up? An x plus 2. So that right there is your common denominator. Do we see it? All right. So you're not going to put two x plus 1s in here. You're just going to use one of them. That's really the only thing about this. Now what we have to do, let's change to a different color. Now what we have to do is that age-old question that I've been asking for the last several days. What do we do to this to get to this? I'm sorry, I lied. What did we do to this to get to this? What did we multiply that by in order to get to this? An x minus 1, because it's already got an x plus 1. It's already got an x plus 2. What did I do different to this to make it look like this? I multiplied by an x minus 1, correct? Yeah. So if I multiply the bottom by x minus 1, what do I do to the top? Multiply the top by x minus 1, right? This is old now, right? This stuff right here we're doing is old stuff. The only thing new we did was going from these denominators to this denominator. That's the only thing new today that we did. All right. Now, what did you do to this stuff in order to get to this denominator right here? Yeah, it's the only thing missing, right? X plus 2. So what do we do to the top? Multiply it by x plus 2. Did you notice I put parentheses around this right here? Because there's two things, right? And both of these are being multiplied by both of these. All right. Now, we're going to put it down here. You ready? First one's not so bad. I just multiply x times x minus 1. What do I get? If you wanted to, watch, you could just do this, couldn't you? All right? Just so it doesn't look so sloppy up there. All right? If you wanted to do that, you could do that. All right? No. Just for the next step, okay? Instead of putting them up here, right, you could have just done this. Does that make sense? All right. So now the bottom doesn't change. I'm just going to rewrite it again. It's a little extra writing to do what I just did, but it's not that big of a deal. All right. Now I see it up here. Now what I want to do is do the multiplication and stick it right here, and I'm going to add my like terms, right? Again, stuff that we've already done in here. Nothing new. So what happens with this? Distribute, so I get x squared minus what? X. Let's do this. What do I have to do here? Foil it. That's right. So let's foil it. So the first, 2x times x, which is 2x squared. And I put a plus because the plus right here. Okay? Let's do the outside. What's the outside? 4x. What's the inside? Minus 3x. And the last, minus 6. Now we're not done. We still have to add like terms, right? We got to add up all the like terms. Kind of tired of writing the denominator, aren't you? But you have to, all right? Don't forget to write the denominator. A lot of people do that. A lot of people get tired of writing it and say, I'll just put it in at the end, and they forget to put it in at the end. So write the denominator every single step, even though it's kind of a pain. Now let's do this. Let's add some like terms. Well, what do I have? Do I have any x squareds? Yeah. I got a 1x squared plus a 2x squared. That gives me 3x squared. So I like to mark these off, don't you? What else do we got? Oh, I got 3 x's here, don't we? We got a negative 1x plus 4. What's negative 1 plus 4? 3. And then I got a 3x minus 3x, which is 0. All right? So it's just a 0. So they just cancel out. So I don't put anything for x, do I? Because it's 0x. What else do I have left over? Minus 6. And I would be okay if you left it like this, but they really want you to, and I understand why they want you to do this. And I think it would be a good idea if you did this. If you circled that and gave that as your answer, I'd give it to you. But what do you think they do? You got a 3 and a 6 here. What do you think they do at the top? Factor out a 3. All right. The reason they do that, I'll show you in a second. Factor out a 3. What do we get if we factor out a 3? We get x squared. It's not x2. It's x squared. Minus what? 2. Right. And then we write all this stuff again for like the 5th time. All right. What about this x squared minus 2? That kind of looks like a difference of 2 squares, doesn't it? But is it? Why not? There's the difference. That thing's being squared, but nothing's being squared to give you a 2. Would you agree? All right. Difference of 2 squares would be like x squared minus 4, or x squared minus 9, or x squared minus 16, minus 25, minus 36. You get that? Because you can take the square root of all those numbers. You can't take the square root of 2 and get a nice whole number out of it. All right? So I just leave it like that. Now, the reason they factored out the 3, and I think it's still important to factor out the 3, is because after you factor it out, maybe, not on this problem, but maybe this thing right here might cancel out with something down on the bottom. Okay? But it doesn't. So I would be fine if you left it like this. This is probably the way the book writes it. Anybody got your book open to that example? They probably write it like this. That's the way I wrote it in my notes. I don't know. It's R.7. So look in R.7 and it's example 8. And that would be your answer right there. So really the only thing new was to get from these two denominators to this denominator right there. Everything else we've covered before. We've done before. Do you see how it all builds? Everybody says math builds. Do you see it in front of your eyes? Absolutely. We take little chunks, right? I teach a little bit here, a little bit here, a little bit here, and then, boom, oops, got too excited. Okay, we put it all together. Okay, we put it all together, and we get a problem like this. Okay, that happens in math all the time. All right, we good with that? Let's do one more, and we'll quit. This is example 9. Example 9. You know what I should do? I should give you a minute or two and let you try it yourself.
We're going to need like 10 minutes.
10 minutes?
Something like that.
How about 3 minutes?
3 minutes is 5 minutes is fine. I think
All right, here it is. Now, what's a little bit different about this? The minus, okay? Remember, eventually you're going to have to distribute a negative through here, so keep that in mind, all right? I'll give you 3 minutes. Ready? Go. At 10:13. See, it's 10:10 right now. At 10:13, you trying it? Come on. You're wasting your time. I'll give you a hint. Before you find a common denominator, what are you going to do? Before you even worry about finding a least common multiple, you're going to do what? Factor. So factor that. Factor that. You give up already? It's just factoring. Look, factor this. Have we had a test on factoring? Or at least we've had a quiz, probably. Yeah, I think at least we've had a quiz on it. And these are easy factorings. These aren't hard factorings. So don't quit already. Yes. Remember I said that other trinomial factoring is probably the easiest factoring you're going to do? Well, I changed my mind. This right here is probably the easiest trinomial factoring that you'll ever do. I did lie. All right, you got less than a minute. It's 10:12. As soon as it turns 13, we're going to go over it. at the very least, you should have this thing factored at 1013. At the very least.
I got a question.
Yeah.
So, once you factor it, when you're starting to put the things together, you put an x.
Then you do that least common multiple thing.
So, is it okay if I just put x plus 1 squared? That's the same thing.
Yeah, because there's two x plus 1s there. Yeah, you could put squared if you wanted. Yeah. I probably wouldn't. I'd probably just keep them x plus 1 times x plus 1, but it wouldn't be wrong if you put it squared. Well, it's 1013. Look at that. All right, let's do this. You ready? So we factor this. What's in common with both of these things? An x. So if you factor out, just an x is in common with both of them. All right, so we factor it out. We get an x plus 1, right? Remember I said this was the easiest trinomial factoring that you'll ever do? Was I right? Yeah. Absolutely. It's plus 1 plus 1. All right? Because 1 times 1 is 1, and 1 plus 1 is 2. All right? Doesn't get any easier than that, I don't think. Now, we do the new stuff that we learned today. We find a common denominator by using the least common multiple. All right? So we got two groups of things. This is one group, and this is another group. So what do? We find out what shows up. What shows up in either play? An x. An x shows up, right? Well, but watch. There's an x plus 1 here, and there's how many over here? So which one do we pick? We pick the one that shows up the most number of times. Okay? Everybody see that? That's our least common multiple. That's our common denominator. Now, we ask ourselves, what do we do to this first denominator in order to get this? Or what's missing from this to here? What do we do to this to get to this? Is it the same? Is this and this exactly the same? No. What's it missing? Another x plus 1. That's right. You see that? So what did we do to this to get to this whole thing right here? We multiplied by x plus 1. So we multiply the top by x plus 1. So I'm going to write it like this. We good? Yeah. Now, what did you do to this denominator, the second denominator, in order to get this big denominator right here? What's the only thing that we changed from here to here? The x. We multiplied by an x. So what are we going to do to this? First of all, put a parentheses, right? And then I'm going to put it out in front. So what do we have? We got minus x times x plus 4. Putting that in parentheses is really important. We agree? All right, let's keep going. I don't need to touch the denominator, so I'm just going to rewrite it again. Ray asked, can you just put x plus 1 squared? Sure, you could, but I'm not going to. All right, I'm just going to leave it like this. That was in the problem. It was x plus 4 in the original problem. See right there? There's the x plus 4. But I put it in parentheses because I had to multiply it by an x. All right? All right, let's keep going. So, what do we do here? Just distribute. That's right. So what do we get? 3x plus 3. Now watch this. This is a negative x, isn't it? So this is going to be what? Negative x squared, what? Minus 4x. That's really important that you do that. Okay? You have to distribute that whole negative through both of those. And we're almost done. Let's keep the bottom. I know it's a pain. Keep writing this every single time, but it's important. All right, so what do we get? Do we have any other x squareds? Nah, so I'm just going to write negative x squared. So I'm done with that one. What else do we have? We got some x's. I got 3x minus 4x, which is minus 1x, right? Negative x. Done with those. What else do I have? Plus 3. Okay, and that is it. That's your answer. It's not too bad, is it? No. All right. Finding the common denominator was the key to today. All right. Going from here, going from this to this, that's the only new stuff that we did today. Everything else we've done previously to today. But it's good practice, right, to do all that other stuff? All right. So let's see. Did I give you any homework on this section? Yeah. 61 to 69 odds. It's not that many at all. Okay? So it's section R7, and we're going to call this C. Now, why did I call the lesson E and I call this one C? Because it's only the third homework. It's only the third homework on this lesson, okay? And here it is. It's page 71, and we are doing 61. So there's only, what? I'd say 5 questions. That's your homework right there. Everybody got that? All right, that's it. Enjoy.